The next session is Pulling the Curtain on Airport Security, and your speaker is Billy Rios. Thank you.
Yeah. Hey, everyone. Really glad to be here. I don't know if everyone knows this, but I was actually hospitalized a couple weeks ago. I didn't know if I was going to make it out, but made it out. So everyone who gave me support, really thank you. Normally, when you go through a presentation like this, I don't mind if people raise their hand in the middle of the talk. But I have a lot of slides here because there's a lot of material. And so if we could just hold all the questions to the end, I'd really appreciate that. So this is probably the alternative title for this talk here, how to get put on no-fly lists. So about me, pretty much just average Joe. I like ICS embedded medical devices. I find them really cool. I travel a lot. I spend a lot of time in airports, which kind of spurred all this stuff. But I want to talk about a little bit about my time in the Marine Corps. I was a lieutenant in the Marine Corps, officer in the Marine Corps. I'm a captain. But a lot of times, I go through airport screening checkpoints, and it kind of reminds me of when I was in officer candidate school. But the one difference is that I only get yelled at when I have Gatorade in my hand, right? So, but there's a couple lessons that I learned as a lieutenant, and probably one of the most important ones was, hey, if it's important, trust what people are telling you, but verify, right? And so I kind of want to hold that theme throughout this entire presentation. And I also want to talk a little bit about the TSA. So they have about 50,000 people at 400 airports across the nation. This is not just stats I made up. You can actually verify this on budget.house.gov. They have a budget of $7.39 billion in 2014. So they get $2 billion a year for offsetting collections. Essentially, the stuff that you pay when you go through an airport, so whether you're a citizen or not, doesn't matter. When you buy an airplane ticket, you're paying for the TSA. So, and by law, they have to spend the first $250 million on passenger security fees on airport facility modifications and equipment, right? So $250 million a year they have to spend on facility modifications and security equipment. So as opposed to me, I'm one guy. I have no budget. I have more than one laptop on mine. I have a couple laptops, some desktops. So, but no one funded this. My company did not give me a year off to do this research or anything like that. I basically just did it on my own time with my own money. What that really means is that anyone can do this. So bought most of this stuff from eBay, took it apart myself, did it in my home office. My wife screamed at me sometimes. My kids tried to play with some of this stuff. I told them not to. But at the end of the day, really anyone can do this. And if you're actually funded and really took the time to kind of understand these systems, you probably understand it better than I would. So, and also disclosure. So we're going to go over a lot of issues here. And I talked to a lot of folks, but more importantly, all this stuff was reported at DHS more than six months ago. So in fact, some of the issues here were reported more than a year ago. So plenty of time. It's not something that we worked on last week. And I want to go over some of the response too, because I found it kind of funny. I initially didn't have this slide in here, but I just want to show you some of the response we had. So the first one's from the TSA. When we first reported one issue almost a year ago, they said, our software cannot be hacked or fooled. So I said, okay, it's pretty comforting. That's good. So, and for the latest ones, they said, we add our own software and protections. So I thought that's pretty cool, your own protections. One of the vendors is just silence. They just didn't even respond. So, and then we actually spoke with someone from Morpho who makes Itemizer, which is one of the devices we're going to talk about. We spoke with them last week. They gave me one call with the engineers, and I don't think they're ever going to do that ever again. But they did send their PR guy out here. So if you have questions about the device or whatever, I think he's in attendance. So that's kind of cool. And so I actually want to talk about scenarios about the custom defenses that we're talking about here. So there's basically two scenarios that I was thinking of because people are like, well, the TSA is saying they have custom defenses and the software that they have doesn't have these vulnerabilities. And I'm like, okay. I was like, I think the TSA doesn't really know about the security issues in their software. That's what I think. I was like, but maybe they do have this elite security team that knows about all these vulnerabilities that I'm about to present here. Maybe they've already solved these issues. They have their custom defenses for all the stuff that I'm about to present. Which means that they knew about the security issues, developed custom fixes and defenses like they said they had, but they never told the vendors. So in fact, some of this stuff is actually exposed on the internet. We're going to talk about that. But that also means that they're hoarding embedded zero-day vulnerabilities. I think it's for the day that they transition from TSA to NSA, but I can't actually verify that, right? But if they do have custom defenses for the vulnerabilities that we're going to talk about, they're actually leaving a lot of other organizations exposed. So if they've developed custom defenses for the stuff that we're talking about, I really hope that they would share that with other organizations, especially their sister organizations in the government that are using some of this software and hardware as well. So, but I think it's scenario one, possibly maybe scenario two. I don't know. So, but what I can tell you is the way they do security is actually very regimented. So that's very, very important if you want to understand how security is done at airport screening checkpoint. So they have these documents, essentially, that outline what it is they're supposed to do at an airport screening checkpoint. This is not a field supervisor decision. The guy at the airport itself that's in charge, the manager or the guy with the bar on the shoulder or whatever, they don't make a decision as to how to lay out the checkpoint. So it's in these documents, essentially. These documents you can find on the internet. So it's not some special document that I got in a special way or anything like that. You can actually download this document from the internet right now and look at it. It's 153 pages, so it's a huge document. And it is very, very detailed as to what has to happen at these security checkpoints. So the way that they're laid out is not an accident. It is not the job of the supervisor to do this. It is defined to them how they need to do this in very excruciating detail. So even the podium that you walk up to has to meet certain dimensions. It has to be this wide. It has to be this tall. It has to be in this way. It has to be put in this place. They really don't leave any room for the supervisor agent on the floor to make any of these decisions. Even the bins have requirements that have to be met, right? And so that's very important when we're trying to understand how security is done at an airport screening checkpoint. And what's more important is the equipment. So it's not like they can just pick any random pieces of equipment and say, I think it's a really cool piece of equipment, we should put this at a checkpoint because it's cool. What happens is they actually tell you which devices you have to have at the checkpoints. And there they are. So see that little, the white device that's second in the middle right there that has a big screen? We're going to talk about that device, and then we're going to talk about this other device where the guy's kind of with his outstretched hand there. It's a time clock. So, but there's specific ones, right? So it's very important. And by the way, the time clock has to be a maximum of 54 inches off the ground and a minimum of 9 inches. So. But they also talk about the IT requirements as well. So this is important as well. So for every piece of equipment inside this document, it tells you, hey, you have to have this many drops. They have to be Cat 5 or Cat 6. They have to go to this place. It has to be done in this way, no more than this length, and so on and so on and so on. So very, very specific. In fact, it tells people how to network them. This is a networking diagram from that document, right? So we see that there is a patch panel someplace at an airport screening checkpoint. Everything's got to be networked to it, and this is the way you network everything to it. So whether it's the podium, whether it's the Kronos clock that we're going to talk about, whether it's the explosive trace detection that we're going to talk about, whether it's the X-ray machine that we're going to talk about, all this stuff has to be on a network in a specific way with specific requirements and basically deployed in a specific way in a configuration. This is not up to the field supervisor. It has to be done this way for every single airport. That's very important to understand. So there's also other basically initiatives that they have essentially to network everything. They want one giant network for all the passenger screening devices. That's important to understand as well. So this is an initiative that was kicked off in 2010. So that network that they have, they call it TSA Net. I'm not going to talk too much about TSA Net because I've never gained access to TSA Net. Because if I did, I'd probably be in jail. But there's another concept that they have called category of airports. So the biggest airports in the United States are called Category X airports. So any airport that you can think of of decent size is probably a Category X airport. The important piece of that is they're all networked together. It's very important to understand that. And so when they say, oh, their stuff's not networked, it's off the network, whatever, next time you walk through a security checkpoint, look down at the devices, you'll see that they're actually connected to a network. You'll see network cables there. So maybe not all the devices, but eventually they probably all will be. So, and then before we continue, I want to give a quick lesson on backdoors. So at some point in time, there's a guy that said, Jim, I can't believe it. There's this girl standing over there, and you're telling them all about our backdoors. And Jim says, Mr. Potato Head, backdoors are not secrets. And he's like, yeah, but you're giving away all our best tricks. He said, they're not tricks. If you actually have the DVD for War Games and you replay the scene with the volume really loud, Jim actually says, Mr. Potato Head, thanks to software like Guided Pro, backdoors are not secrets. So when you think about backdoors and how they get put in place, a lot of times what people say is, hey, a backdoor is code put in by a malicious actor in order to gain persistence or access to a particular device, right? So I have never seen that with any of the screening devices I looked at. I looked at a lot of medical devices, I haven't seen that there. I looked at some ICS devices, I haven't seen that there as well. So, but what I have seen are debugging accounts, where a manufacturer will create a device, and during the creation of the device or the creation of the software, they create an account that has a lot of privileges because they're using it for debugging, and maybe they publish the device or put the device into production, and they forgot to disable that account or some interface that's used for debugging. So that's not as common as what we normally see, though, which is what we call service or technician passwords. So I'm going to talk about service and technician passwords here. So technician passwords, service passwords, very common in embedded devices, those are backdoors. Those are backdoor passwords. Why are they backdoor passwords? Because they're often hard-coded into software. We're going to show some examples of that here in a second. So sometimes the application that runs on this device, whatever, depends on that password to be there. It will not work if the password is changed or modified in any way. So how are these passwords different than other stuff? Well, let's talk about how they get there. So if I'm a vendor of a device, let's not even talk about security screening stuff. Let's say you want home automation. I want a really cool sprinkler system that waters when my grass needs water, right? Automatically. I want it to be really cool, and I want to check the status on my iPhone. So normally what people will do is they will not go out and buy the components for this and install it themselves. They will call someone and say, hey, I need you to cut sheetrock, install these cool sensors in my house, install this central controlling thing, and I need this thing to be accessible via my iPhone. And someone will roll out there and do the installation. And so sometimes that's the manufacturer, sometimes that's someone else. We call those people an integrator. And so what the manufacturer does is they think, we're going to install these devices. We don't want to deal with the hassle of asking the user, like, do you remember what the password is for this? Or did you ever change the password for this? Or do you remember how to get access to this? Or why did you change this thing? They don't want to deal with that. So what they end up doing in anticipation of doing service and maintenance in the future is a lot of them just hard code a username and password in the device, in the software itself. So when their technician shows up, they can say, I already know what the password is for this device. I don't need to ask anyone. I can use this username and password. I'll gain access to the device right away. I can do service and maintenance. So that's how these passwords get into devices. It's actually very common in the embedded world. I don't know why, but it is. So the reason this is different from other vulnerabilities, like, hey, I could do reverse engineering, find a buffer overflow. The reason this is different from, let's say a buffer overflow is I've never seen someone take a dependency on a buffer overflow. But there are multiple dependencies on backdoor passwords. So for example, if you're an organization that has a backdoor password in your embedded device, you probably have technician software on a technician laptop that depends on that backdoor password in order to service that device. That'll do the authentication for you. You probably have training for your technicians to tell them what that backdoor password is. And your technicians in the field probably know what that backdoor password is. And if you change that, you actually have to change these business processes as well. You have to change your training documentation. You might have to change a laptop software that you have for your technicians. You might have to update all your technicians in the field and make sure that they know what the new password is. And they also have to know what the old password is because maybe there might be some device that's not updated. They still need to gain access to that. So you have this business dependency on this backdoor now. And that's why they're so dangerous. The business that put the backdoor in place has a dependency on that backdoor. So and that's why this is a little bit different than other security vulnerabilities. So, but the problem is that once someone else discovers the technician password, it's a backdoor password, right? I'm not a technician. I don't service passenger screening equipment, but I know the passwords to these devices now. So, and that's extremely dangerous. In most cases, they actually can't be changed by the end user. You cannot change some of these passwords. We'll give an example of that here in the future. And then once the initial work is completed, like once I buy a device and get a password, a backdoor password out of a device, it usually scales. It usually works on every other single device of that make and model. Sometimes it works on the other devices of other different makes and models if they have a dependency on a particular component that I'm looking at. So it scales really well. And so that leads us to the first device that we're going to talk about. The first device that we're going to talk about is RepScan 522B. It's a little bit of an older X-ray scanner, but I think there's some important lessons to learn here. The version that I got is actually running Windows 98. I was like, oh man, this is crazy. So, but talking to the vendor, they've upgraded and now runs Windows XP. So that's not a joke. So when an operator, when a TSA agent or screener logs into this machine, this is the login screen that they see. So it's pretty cool. If you look at some of the configuration files, they have their passwords in. This is actual like service password for the RepScan 522B, right? So just straight up in system information. It's like, oh yeah, here you go. You need this right here, right? So I'm like, okay, that's pretty interesting. There's another piece of software actually that's on here that's called TIP. And so when you run the TIP, you basically enter an ID and a password. It's like, hey, how did you know what the ID and password was? Because there's a bunch of files that have the IDs and passwords in clear text as well, right? So, but that's not so bad because usually you have to have access to the device to understand what that is. So what if you didn't have an ID and a password? Like how could you gain access to this device, right? So I was just like throwing random stuff out there. And I threw this at the login screen and I get this error, right? It's a data integrity problem in the user's record. And then it's like, I'll just log you in, right? So I'm like, oh, that's very crazy, yeah. So this is basically the pseudocode. It's like, hey, check the password, if authenticate, else fail. But hey, if there's ever an error, show an error message and authenticate the user, right? So that's pretty crazy. And then once you get access, as a non-user or whatever that is, you can actually look up the passwords for the other users, right? So a lot of the integrity and logging is definitely gone on this device. So it's like, oh man, what happened here? What happened here, right? So, and then we're gonna actually talk about what that software does. It's called TIP, right? So I'm guessing that the frequency of threats coming through hand-carried luggage is probably pretty low. And someone had this bright idea. They said, you know what we should do? We should test our screeners to make sure that they're really good. And so we wrote this software that basically allows us to inject threats into people's luggage. And if the TSA sees the threat and pushes the button, then you see the green happy sign over there that says, hit, you discovered a fictional threat, you're awesome. And if the gun goes by and they don't detect it, then they get the bad sign, the red one that says, you suck, you missed, right? So, and the way that it works is essentially you have categories of threats like bombs, guns, all sorts of stuff. And there's essentially a configuration file. And that's one of the configuration files for a .32 caliber chain gun, right? Keychain gun. And then they have images, which are put into the screener's view, right? So overlaid into someone else's luggage. So this is probably a reason why you get randomly screened. We're like, oh, we need to look in your bag, right? And there's nothing there. Or unless there's Gatorade there, then they freak out. So, but I'm like, who did the threat model on this, right? Like you have software that's really crappy, can't really do authentication, that allows you to modify the screen that the screener is looking at by design, right? So, kind of crazy. But I guess TSA found out too, because they canceled the contract with this vendor, actually Rapiscan. This is public knowledge. And this is what they said. This is a quote, actually. TSA has strict requirements that all vendors must meet for security effectiveness and efficiency. It does not tolerate any violation of contract obligations. TSA is responsible for the safety and security of nearly 2 million travelers screened each day. And we're like, man, that's pretty powerful. So, and then there's some more quotes. I think these came from Congress, and they're like, what we found out was there's this foreign-made part in Rapiscan X-ray scanners. And I'm like, that sounds pretty bad. And apparently, the foreign-made part was manufactured in the People's Republic of China. Right? So I'm like, oh, okay, yeah. And then we find out that, like, hey, that foreign-made part was a simple electrical item with no moving parts or software. And then we find out that, like, the foreign-made part was actually an X-ray light bulb. I'm like, wow, all this over a light bulb, right? It must be pretty hardcore. So that leads us to the next device we're going to talk about. So it's this device here. It's called a Kronos. So this is actually a Kronos at an airport. So, and if we go back to that document, it is like the approved time clock for TSA, right? So networked into their network for all the passenger screening devices. And so that's my Kronos right there that I bought. I'm like, wow, that's very, very similar, right? So it's cool. So I pop this thing open. That's the first thing I always do, right? Take the case open, look at the guts, see what's going on in there. It's like, wow, this board's pretty beautiful. I like this. It's really cool. And then I flip it over. It's like, oh man, this main board's like made in China. Wow. So light bulb, main board, light bulb, main board, all on the same network. I'm like, that's kind of interesting. So, but there's some other interesting stuff too. So it's a Power PC. It's run VxWorks, has FTP listening, has Telnet listening, has a web server listening. That's the server banner. And when you browse to it, it basically does a www authenticate basic realm of browser, right? So that's how you would kind of fingerprint this thing if you wanted to look for it. If you log into the device, this is basically what you get. You get a shell if you telnet into it, right? So it's got a lot of weird stuff. On the left-hand side are all the devs, devices. Probably most important is number 3, which is flash 0. That's actually the file system for this device. And then there's some other commands that kind of get weird, like if show is actually kind of the IF config and that sort of stuff. So, and then as we look around, we see this application directory, and the application directory has a jar file. And I was like, dude, this thing has Java. And so I think it was the one time I was actually happy that Java was installed on a machine. So, because it means that if you do want to exploit this device, you don't have to write PowerPC exploits. You can just write Java exploits and call Java. So pretty straightforward. So in a configuration file, there's a username and password, right? You're like, oh, this is not good. So, and this is the top line there, the boot line is basically how it takes the compressed L file and then expands all the operating system, right? Or the OS. It's pretty cool. And then it's like, hey, I got this username and password here that you should probably use. But if we look deeper, actually into the application code, we see that the application actually depends on that username and password to be there. So if you were smart and you're like, you know what, I'm just going to change it. I don't care. I'm going to go ahead and tell that in, and I'm going to change that password. The application will actually break. The application depends on that password to be there. This file is actually from a maintenance file for a service technician. So And then knowing what we know about the actual banner, we can take a look on the internet and see if there's any of these on the internet. So I found one, San Francisco Airport. We're like, whoa, man, I fly out of SFO a lot. And so about 4 months ago, contacted DHS. DHS actually helped me get this one taken offline. So you can browse to the IP address, there's nothing there. But it was there. And if you go to Shodan, I think this artifact is actually still in there. So we know that San Francisco Airport had its Kronos online at some point in time. So we basically have a backdoor for FTP and Telnet. It's in 2 different places, probably in a lot more places, but we know that it's in a configuration file that basically when the OS gets expanded. We also know that it's in another file called main validation, probably maintenance validation, in a class file within the MAM jar, which is the application that actually runs to scan all sorts of stuff. There's also a web backdoor. I think it's mainly read-only, so it's not big of a deal. But there's 6,000 of these on the internet right now. So, except for the TSA ones, because they have custom defenses against this. So here's a thought. Foreign made mainboard, TSA net, which can track TSA personnel on the floor at any given point. Hard-coded FTP password, hard-coded telnet password, which gives you shell, and then hard-coded web password, right? So, not looking very good, right? Not looking very good. I wonder if TSA knows that Kronos has a Chinese-made mainboard. I wonder if they validated that the ones that they have in their TSA net have been made somewhere else. And I wonder if they know if the software has backdoors, because when I reported this to DHS, they didn't come back to me and said, yeah, we know about this. They said, oh, wow, this is really bad. So trust what you're hearing, but verify the engineering, right? So, and then we're going to talk about another device here. This is called an itemizer. So, and actually a representative from this company is here if you want to ask some questions, PR guy. So this is one from an actual airport. So this is not my itemizer, this is one from an airport. So we see that it's networked. And you can see that you can actually get really close to these devices. So this one has a USB on the back. You can do all sorts of weird stuff. But probably the most important thing is that it's networked. And then they're in places where people can't really see what's going on with them. So if you take a look at that one, or you take a look at that one, it's just kind of off by itself, right? And it's kind of neat. I'm like, okay, it's just off by itself. So I thought this was pretty cool, so I bought one, right? And this is what the interface looks like if you were to stand in front of it. And basically you have these modes, so explosives, narcotics, or both, right? And what that shows you is this is how it detects. So these are the substances that it detects as you have this thing loaded up. So TNT, nitro, cocaine, heroin, THC. So, and then basically how it detects is kind of in here as well. All this is stored in one file called config.bin. So the way this whole thing works is the x86 processor, we'll look at this in a second, runs Windows CE. The version that I have did Windows CE 3. The disk is on a chip, about 7.5 megs, main program, PS2 interface, floppy interface, and new ones have USB interfaces. Has IRDA, I don't know what for, but yeah. So the file system at its most basic level looks like this. ITMS-CE is the main program that runs. There's a users.bin file that has all the user accounts that you create. When you create a user, it gets stored in users.bin. When you set the detection levels for a particular substance, that gets saved in a config.bin. So if you were to own this device and change the config.bin, you would actually change the way the device is detecting substances. So you could turn that all off, you can change the way it detects, you could make it so where certain substances are not detected, whatever you want. It's all in the config.bin file. And then there's options.bin, history.bin, and alarms folder. Those aren't as important, I think, as the top 3 there. And so that's my itemizer. At home, I actually have 2 of these, so that's kind of neat. If you tear this thing open, this is what it looks like on the inside. So there's actually something that happened to me that actually kind of terrified me. I broke this thing open, I saw a radioactive sticker on it. I was like, oh my God, I just owned myself. Like I knew this day would I knew this day would come. Like, oh man. And but then I realized that there's a protective case and I guess the radioactive distance for this certain radioactive material in there is pretty low. So I was like, okay, I'm alive. Let me get my kids away from this thing. So it has a Pentium processor, which is really good for me because that means it's x86 architecture. It means reverse engineering should be pretty straightforward. That is the chip that has the software. So that is essentially the hard drive of the device, right? So, and if we pull all the software off and throw like the authentication routines into something like IDA, we see all these weird kind of strings that at some point in time get compared during the authentication, right? So I'm like, oh, wow, that's pretty interesting. So let me walk you through what we saw here. So this is a picture of the user's menu when you log into this itemizer. So you see operator 1, maintenance 1, administrator 1, super user 1, and then you see a slew of users, right? So the way that this works is those 4 top accounts are basically default accounts. And then the other accounts that you saw are actually users from the organization that previously owned the device before I had it. They forgot to take their accounts off of there, but that's okay. When you create those accounts, those get added to the users.bin. If you delete the users.bin file, what happens is those accounts get deleted, and these 4 accounts up top have their password reset back to the default, which are actually hard-coded into the binary. So that's okay. I also saw this sticker on my itemizer. I don't know what it means. And then I looked at the users in binary, right? So operator 1, maintenance 1, administrator 1, super user 1, administrator 2, and super user 2. I was like, wow, that's pretty interesting. So let's compare the two, right? So when we look at the built-in accounts, we see that there is some similarities, but there's also some differences, right? So those are the 2 backdoor accounts. There's an administrator 2 account and there's a super user 2 account, right? And the problem with this is that they don't ever show up in the user menu, right? So if you take a look at this, I am actually logged in as super user 2. And if you look at the user menu, there is no super user 2, right? And so the problem with this is because if you want to delete a user, if you are an end user, you bought this thing, I want to delete a user, I want to change the password, or I want to add a user. I go to the users menu, I select which user I want, and then I click modify, and it shows me, hey, you can change the password here. If the user doesn't exist in the user menu, you can't actually modify that account. So it's just not there. You can't modify the password, you can't delete the user. If you try to create a user called super user 2, it won't let you, or administrator 2. So with this account, you can do whatever you want. So there's actually an advisory released on this particular vulnerability by DHS on July 24th. So it's pretty cool. It's pretty light on details. It says, hey, independent researchers identify hard-coded credential and the Morpho Atomizer 3. They haven't produced a patch, an update, or a new version that mitigates this vulnerability. And I think more importantly, they're like, hey, they're not going to address this vulnerability. So I'm like, oh man, that's not good. So, but we talked to the guys from Morpho. I actually have some good news, like a little bit of bad news, but maybe you can get some more stuff out of this guy. But so the good news is that Atomizer 3 is actually not used by TSA anymore. So they are using the latest version called the DX. So that's cool. What I also found out is the hard-coded passwords that I showed you will not work in the DX. So that's why we showed them to you. So you can't take that password and walk up to a TSA device and log in with that password. So that's pretty good news. The other good news is because we're going to give this talk at Black Hat and show people what the passwords are, Morpho is actually going to patch that issue. It's going to be out by the end of the year. So if you have an Atomizer 3, you can thank Black Hat for getting you a patch for this. I asked them not to just change the password to a different password, but to remove those accounts if they could, right? Like those accounts need to go, right? So I think some of the bad news is, and maybe you can get more out of the PR guys, I did have a conference call with some of their engineers, and the PR guy was on the call as well. And it sounds like there's actually a new algorithm to generate super user passwords on the new version, right? So technician passwords still do exist on the new version. It's a rolling password, right? So that means it's not just one little string. You probably have to extract an algorithm. And so, but the PR guy tells me that that's not the case, and then the details get kind of fuzzy. So maybe you can talk to him and get more information about that. So I think that's cool that they're going to patch this. This is pretty neat. I haven't heard from the other vendors about whether patches are coming out for their devices or not. So, and then so this really leads us to like, hey, should we blame the vendor on this, right? There's 3 different vendors, 3 different pieces of equipment. Should all the blame be put at the vendor's feet, right? It's kind of the question. And I actually don't think so. So I know that places like TSA, they depend on this equipment to do their job, right? Like a TSA agent cannot swab your hands and sniff for the presence of explosives and narcotics, right? Or maybe they can, I don't know, but I'm thinking that they cannot. So they actually need this equipment to do their job. It's not a nice to have, they need this equipment. And I don't think the operators really understand or should be required to understand how the software works or how to detect exploited devices or whether devices have hard-coded passwords or backdoors and things like that. Not the people at the screening checkpoints, right? That's not their job. And looking at things like the rapid scan tip, where we can actually inject images into image and screens and stuff like that, I don't know if there's been good threat models conducted on some of this stuff, especially when you can bypass logins and you find hard-coded passwords and things like that. Maybe there's custom defenses for that, I don't know. But to me, it seems like that hasn't. And when we look at like the OR1 equals 1 and the weird authentication stuff and the hard-coded passwords and config files and that sort of stuff, I don't know if these devices have been audited even for the most basic security issues, right? Because those issues are actually pretty basic. So, but the more important piece is, the vendors will develop the device to whatever the TSA tells them. So in fact, there's already a certification process for this equipment that TSA owns, and that's how you get into that little list and the pictures and all sort of stuff, into this documentation. And so whatever requirement TSA puts onto the vendors will do it. And I think TSA has a responsibility to do something like that. Because if you're a small courthouse, or if you're a small prison and you have these devices, I don't think you have enough clout to tell a vendor how to do their software engineering. But if you have $250 million a year that you have to spend on equipment, some people might listen. I know I would listen. So, and oh, by the way, like we paid for all this stuff. So I paid twice because I had to buy this software. But you buy all the hardware that's actually at a checkpoint center, right? So, and then we did these audits. So what I really hope is that someone trusts what the TSA is telling us about their devices, the way they certify them, and the way they do cybersecurity. But more importantly, I hope someone verifies that the engineering is reality. So the custom defenses that they have, the security stuff that they have in place, or they say that they have in place, the vulnerabilities that they know about, I hope someone verifies that that's a reality. And then these are embedded devices, right? So this could easily be a little device that keeps track of your conference room scheduling or something like that. And you're going to buy embedded devices in the future, especially with IoT coming. I would hope that you would do the same for your devices, right? Understand what the software is running and what it's doing, or at least make an effort to do that. So because this is a real big problem, especially the hard-coded passwords thing. So especially if you're a corporation, you have a lot of clout. And do that before you fork over the money, because otherwise it doesn't work. If you do this after you pay for the devices, you don't have as much clout. So, all right, I do want to take some questions here. I don't know if there's any questions at all. Hope you guys enjoyed the talk. So I know I went kind of fast here. But, all right, there's